This is Geometry A, Unit 3, Lesson 1. We're getting into logic and proof this unit, so a lot of fun is to be had. This first lesson is on conditional statements, so there's a lot of vocabulary involved. So you may have already noted the key words for this lesson in your vocabulary notebook. Jot them down. You're going to get some definitions here shortly. All right, the first word that we need to define is conditional statement. Conditional statement. Okay, they can be defined as if blank, then blank statements. Though they're not always written with the words if and then, they can be written with the words if and then. Let me give you an example. If I have a Dalmatian, those are those spotted dogs, fire truck dogs maybe, then I have a dog. Okay, that's an if-then statement. It's a conditional statement. If a condition is met, I have a Dalmatian. Then a condition is fulfilled, or then a conclusion is reached. I have a dog. Okay? There are some parts to this statement. The if part is known as the hypothesis. Now note that's not the same as a scientific hypothesis, which is a reasonable idea about why something is true. But a geometric hypothesis is the if part. The if part of a conditional statement. It is the condition that is met to begin with. If I have a Dalmatian. Hypothesis, I have a Dalmatian. Then, the then part is called the conclusion. The then part is called the conclusion. Conclusion. So I have a dog. Now, not all statements are true. Not all statements are false. Some are true, some are false. This particular statement, if you think about it, is true. If I have a Dalmatian being a type of dog, then I have a dog. So this statement has a truth value. So that's another vocabulary word, truth value of true. Okay, it has a truth value of true. All right, so now there are things we can do with these statements, and these are things that people often do. One of the most common misconceptions in logic comes from something known as the converse. The converse. Okay? And the converse of a statement switches the hypothesis and conclusion. Okay? A implies B, or if A then B, becomes B implies A. Let me show you what I mean. If I have a Dalmatian, then I have a dog becomes if I have a dog, then I have a Dalmatian. Okay? If now the hypothesis of this statement is now I have a dog, right? And the conclusion is I have a Dalmatian. Think about it in this case. If I have a dog, must I then have a Dalmatian? The answer is no, right? So note that A implies B, became B implies A, and this has a truth value of false. Okay? Because having a dog does not mean you necessarily have a Dalmatian. You could have a German Shepherd, you could have a Husky, you could have a Chihuahua, right? And that brings up another vocabulary word, something called a counterexample. Counterexample. Here, let me put this in red. Counterexample. In this case, the counterexample is, I'm going to make a counterexample of a German Shepherd. Okay, it's a counterexample because it makes the condition true. It meets the condition, but it does not meet the conclusion. It makes the conclusion false. So a counterexample is an example that meets the conditions of the hypothesis, but does not meet the conditions of the conclusion. The hypothesis is true, but the conclusion is false. That's a counterexample. And it only takes one counterexample to prove a statement false. Right? So that's the converse. The converse. Converse, A becomes B, switches to B, B implies A. All right? There's another word we need to know, and that's negation. Okay? So it is everything something is not. Everything something is not. Example, I don't have a dog, or I don't have a Dalmatian. I don't know what I have, but I don't have a Dalmatian. Okay, by the way, the symbol for that, we use a tilde, is not A. Not A. I don't have a Dalmatian. Now, it's not opposite. So, for example, the negation of black is not white. It is, the negation of black is not black. Anything but black, right? The negation of wet is not dry, but the negation of wet is not wet, right? So it's very important that we are very clear on what negation means. And we need negation to define the next word, which is inverse. Inverse. That's when your A implies B becomes not A implies not B. So our if I have a Dalmatian, then I have a dog becomes if I don't have a Dalmatian, if I don't have a Dalmatian, then I don't have a dog. Okay, notice this is not A implies not B. Not A, not a Dalmatian, implies not B, not a dog. And if you think about it, can you think of a counterexample? If I don't have a Dalmatian, I have something other than a Dalmatian, do you necessarily not have a dog? Well, again, German Shepherd comes to mind as a counterexample. A German Shepherd is not a Dalmatian, but it is a dog. So it is not a dog, it is a dog. So this statement is false. And the counterexample of German Shepherd makes it false, demonstrates that it is false. Okay? All right, there's one more word we need. One more word, so we're almost there. And that is contrapositive. Contrapositive. Start with the conditional statement A implies B. If A, then B. The contrapositive switches and negates. Not B implies not A. Think about it. If I have a Dalmatian becomes, if I have a Dalmatian, then I have a dog becomes, if I don't have a dog, then I don't have a Dalmatian. Let's go ahead and write that out. Okay, let's scroll up here a little bit. All right, so if I don't have a dog, then I don't have a Dalmatian. Okay, so this is not B implies not A. Think about this one. If I don't have a dog, if what I have is not a dog, then obviously what I have cannot be a Dalmatian because a Dalmatian is a type of dog. Okay, so this is a true statement. And you'll notice it's true because the original statement was true. The contrapositive, and the original statement always have the same truth value because they're logically equivalent. Okay? Let's represent this in a little bit of a Venn diagram, if you will. Okay? Venn diagram. There. Let's scroll up here. And the Venn diagram helps to make sense of the situation quite a bit. Dalmatians are a type of dog. So a Dalmatian is a subset of the bigger group known as dog, right? The bigger group known as dog. So Dalmatians are a subset of a bigger group known as dogs. So, dog. So if you're in the Dalmatian subset, you're obviously in the dog subset. So the statement is true. And notice that it's always if small, then large on the Venn diagram. If small, then large. If you're a Dalmatian, then you're a dog. If you're a dog, then you're a Dalmatian would be false because there are other subgroups inside the dog group, like German Shepherd. Hit the wrong thing. Okay. So like German Shepherd is another group inside the dog group that disproves if you're a dog, you're a Dalmatian, because you could be a German Shepherd, which is also a dog, right? And the contrapositive actually makes sense too in this case. Let me analyze this. If you're not a dog, that means if you're outside the dog group, then are you necessarily outside the Dalmatian group? And the answer is yes. So if you're not a dog, you're not a Dalmatian. And that's why it works the way it does. All right. Hopefully that helps.